everyone, Miss Hillams here. And today in this video, we're going to be learning about the basics of electric and magnetic force. So when you get back to school, we're going to be diving a lot deeper into electric force as well as magnetic force. And pretty interestingly enough, both of these forces are very closely related. So this video will help us get through the basics, so that way when we get into class, we can get down to the nitty-gritty and not really have to spend so much time on the basics. So we'll get started. Electric force is what we're going to start with. And when we think about electric force, we have to go all the way down to the smallest particle that exists on Earth, which is an atom. So all matter, anything, is made up of very small particles that are called atoms. And when we look at an atom, it's actually able to be broken down into even smaller parts. So atoms are the building blocks of all matter, but what makes up an atom is truly the building blocks of all matter. So we have three parts in an atom. We have a proton, which is positively charged. We have a neutron, which is neutral. Neutral, it has no charge. And we have an electron, which is negatively charged. And these kind of symbols show what they are. So plus for positive, a negative for negatively charged, and then nothing for neutron. It's neutral. It doesn't really have one side or the other. So when we look at electric force, we need to know the parts of an atom because in order for an object to be electrically charged, and again, think of electricity or electric force as static electricity. We're not really going to be getting into electricity that powers our house or our electronics. We're mostly going to be talking about static electricity. So like when you shock someone in the wintertime after walking across the carpet, or when a sock gets stuck to your shirt in the dryer. That's the type of electric force that we're going to be talking about. We're not really going to get into moving charges all that much, which is how electricity happens. All right, so when we are looking at a charge is considered to be a physical property. It can change within an object pretty easily. And an object can either have a positive charge, a negative charge, or no charge at all. And it really depends on how many electrons or protons an object has in their atomic makeup. So anytime there is a charge, a force is exerted. So a push or pull can actually happen on objects or from objects that are electrically charged, meaning they have more electrons or less electrons, depending on, a few circumstances. So the law of electric charges states that like charges repel or push away from each other, and opposite charges attract. So we always want to think of, when it comes to electric force, opposites attract. So if we have a positively charged object and a negatively charged object, they will attract and they will stick to each other, kind of like your sweatshirt and your sock in the dryer when they get stuck to each other. They are differently charged. One is positive, one is negative, and they will attract. But let's say we get two positively charged items, they will push away from each other. Same thing with two negatively charged items. They will also push away or repel from one another. So in the case of electricity, like charges repel when they're the same thing, they're like one another. They repel, and opposites attract. All right, so when we are getting further into electric force, and we'll get into this more when we actually get back to school, but we're going to talk about the different ways that an object can become charged. And basically, an object will become positively charged when it loses electrons. So if it loses the thing that makes it negative, think of it as, a number line. And if you get rid of, negative numbers, you're actually, getting a positive number instead. So a positively charged object, when it loses electrons, it becomes positive. Meanwhile, if an object gains electrons or it gets more of the negative force, it becomes positively charged or negatively charged. Sorry. So if it gains electrons, if it gets more of the negative thing, it's going to become negatively charged. And we'll go over when we get back to school how our objects can change their charges. There's 3 different ways. There's friction, conduction, and induction. But for right now, all you need to know is that an object will be positively charged if it loses electrons, meaning it's lost its negative matter, and so that means it has more protons compared to electrons, so it's positively charged. Whereas an object will become negatively charged when it gets more electrons. So it gets more electrons than it should have. So now we call it negatively charged. Okay. All right. So that's the basics for electric force. Now we're going to kind of skip ahead to magnetic force. Okay. So when we're talking about magnetic force and the basics of magnetic force, it's actually really, really similar to electric force, meaning that we have attraction and repulsion, and we kind of have these 2 different, not charges, but kind of charges when we look at magnetic force. So let's get into it. When you bring 2 magnets close together, the magnets will exert a magnetic force on each other. And we've probably seen this time and time again with magnets on your fridge, magnets on the board at school. There's plenty of magnets in the world. And basically what happens is, and we'll get more into this again when we get back to school, but these magnetic forces result from spinning electric charges within the magnet itself. So a magnet is also made up of atoms, and it's kind of dependent upon the arrangement of the atoms, which will make an object magnetic or not. But we'll get more into that when we get back to school. For now, all we need to know that sometimes the magnets will either be attracted to each other, they may be repelled or repulsed from one another, repulsion, or they may even rotate too. Okay, so let's kind of get the lowdown on when magnets do each of those. So if you hold a magnet a certain way, they'll pull together. But if you flip the magnet around, you may notice that it will actually push apart. Sometimes you try to put 2 magnets together, and it almost feels like there's an invisible force field that's like trying to keep them apart. That would be magnetic force. And basically, the reason why this happens is because magnets have 2 poles. If you look over here, and sometimes on diagrams of magnets, you'll see there's an N and an S. That stands for North Pole and South Pole. And depending on how those poles are oriented or kind of displayed, your magnet will either attract or repel. So the magnetic force between magnets depends on the poles of the magnets and how they line up. Just like electric force, like poles will repel. So if you try and put 2 of the same type together, they're going to push away from each other. But opposite poles will attract. Like poles repel, opposites attract, just like electric force. So that's kind of a nice little rule that we can remember for both. And again, this kind of just shows an example, like literal pictures of an experiment you can do to see the difference between the North Pole and the South Pole in a magnet. Over here, we have 2 like poles together, and they're pushing one another apart. If you look, the strings are at an angle from one another. They're not parallel. Again, the same thing happens with 2 South Poles, but when you put the North Pole and the South Pole facing each other, they will now pull together because now it's an attractive force rather than a repulsive force. All right, that is the basics that we are going to learn in this video. Again, super simple. When we get into school, we're going to go over how an object will gain or lose electrons. What are the different ways that can happen? And we're also going to talk about magnets and how does a metal, item become magnetically charged, and kind of what could happen to a magnet that could either make it stronger or make it weaker as well. So we're going to learn a lot more when we get back to school. But for now, what you can do is if you take a look at the electric and magnetic force basics exit pass, you will just answer these 7 questions to the best of your ability. Remember, you can always go back in the video if you're not sure, watch it again. But other than that, when we get back, we'll dive deeper into electric and magnetic forces. So if you have any questions, please either leave a comment on Google Classroom, or as always, you can pop into your office hours. I'll see you guys later.